All right, we're going to talk about how to identify parts of an ellipse given the equation. So let's look at just examples 5 and 6. Again, these are going to refer back to kind of the formulas that we put on the front page of our notes, so you can refer back to those if you need to. This one says determine the center, vertices, foci, and eccentricity for this ellipse here. So the first thing that we want to do, identifying the center, right? That one's pretty straightforward. We've already talked about the center is pretty easy to find from that h and that k. So here's my h, here's my k. We take the opposite of both of those values to find the center of the ellipse. So we're going to say -3 and a +5 there. Okay, the next ones that we're looking for then is our vertices, and then once we find those, we are going to find the foci, and then again to finish off, we're going to do the eccentricity, and we'll calculate that. So let's talk about the vertices. Remember, looking at the equation, we can tell if this one is elongated horizontally or vertically by looking for the larger value. In this case, the larger value is underneath the y, which means that this one is elongated vertically, right? This deals with the major axis here, so this one must be a squared. So if a squared is 25, that means that a is equal to 5. And if b squared is 16, then b must be equal to 4. Now again, if we know where the center is, remember if this is the major axis vertically, then when we want to find the vertices, and again this goes back to page number 1, we're not changing at all the x value. That h value is going to stay the same, but we do want to add that a value to figure out what that top vertex is, and we want to subtract the a value to figure out what that bottom vertex is. Okay, so in our case, the vertices, we are going to have that -3 will stay there. Our k value was 5 from our center, and we're going to add or subtract the a value. Now again, this a value was 5, so we're going to add or subtract 5. Now when we do that, and I'm going to write this over here where my vertices are going to go, so that would be -3 comma, I'm going to do the positive sign first, 5 plus 5, that gives me 10, and then my other vertex would be at -3 comma, now I'm going to use the subtraction sign over here, so we do 5 minus 5, and that would give me 0. So we know that those two vertices would be at -3, 10 and -3, 0. The foci, again, are along that major axis. One's going to be up here a little bit, one's going to be down here, but remember they relate to the c value. So if we want to find the foci, again, we're not going to change the h value, but we are going to add or subtract the c value. Okay, now to find the c value, remember that c squared, again, going back to the front page, is equal to a squared minus b squared. So if we want to find that, we're just going to use the values that we know. We don't know c squared, but we do know that a is 5, and we do know that b is 4. So c squared is 25 minus 16. Essentially, c squared is equal to 9. So that means that c must be 3. So if c is 3, then to find my foci, I'm going to have the center there, but I'm going to add or subtract 3 to find those values. So again, I'm going to write this over here, where my answers are, and I'm going to have -3, then we're going to do the 5 plus 3 to get 8. Oh, too many commas there. And we will do -3 comma, then we're going to use the subtraction sign, so 5 minus 3 would give me 2. Okay, again, eccentricity, just remember eccentricity is the ratio of c over a, so the distance to the focus or to the vertex. So in this case, the eccentricity is going to be c, which we ended up with 3, over a, which our a value was 5. So there's all of the pieces that we were looking for in this case, okay? Very similar on number 6, it's just not in standard form yet, so we need to put it in standard form. So again, we're going to follow the process of completing the square. So I'm going to split up my x values and my y values, so we've got 4x squared minus 8x, there's my two x pieces. Then I'm going to leave a gap. Then we put in our y values, so we've got y squared and 4y, and we leave a gap, and we move the negative 8 over to the other side, which leaves a positive 8. Before we can complete this square, we do need this coefficient to be 1, so that means we need to divide a 4 out. So we divide the 4 out and we get x squared minus 2x. Again, I'm going to leave that empty space so I can fill it. Now this one doesn't have a coefficient in front of the y squared, so I'm just rewriting it so that we can fill that in. Okay. Again, we take half the middle term and square it, so half of that is 1, 1 squared is 1. Remember what we really put in right there was a 4, so on the other side to balance it out we add 4. In this next piece, again, we take half of that, which is 2, 2 squared is 4, so again to balance I'm adding another 4 on that end. And then we go ahead and factor. So we've still got the 4 out front, we get x minus 1 squared plus y plus 2 squared. And then on the right side we have 8 plus 8, which is 16. Now standard form means that it's equal to 1, so we need to divide everything by 16 so that we only have a 1 over there. Notice when you do that, again, that leaves us with 1. In this middle term, we are going to have y plus 2 squared, and the 16 can't simplify with anything, so it stays there. Notice you have a 4 and a 16 here on the left. So 4 goes into that once, into that 4 times. So essentially you have x minus 1 on top over 4. Okay. Now this is now in a position where we're going to do the exact same thing we did on the upper one. So I'm going to work through this one pretty quickly. Again, this is the larger number, which means that's the a squared. And this one must be opening vertically like the other one. So again, if a squared is 16, then a is equal to 4. And this must be then b squared. So if b squared is 4, then b is equal to 2. Okay, so again, we're going to find the different pieces. So the center is going to be taken from our equation here. We use our h and our k, and we can find the center. Our vertices, we find them the same way that we did the last one. Again, this one's moving up or down, so the x value is not changing at all. But we do want to add and subtract that a value. So again, our vertices are going to look like we've got 1, but then we are going to take the negative 2 and we're going to add and subtract the a value. Again, that a value was 4. So if we do negative 2 plus 4, that gives us 2. And the other one would be 1 comma negative 6. Okay. Foci, same idea, but instead of adding subtracting a, we need to add or subtract the c value. So again, we don't know the c value, so we need to find that. So we take c squared is equal to a squared minus b squared. So we plug those numbers in. C squared is equal to a squared, which a is 4, so that's like 16, minus b squared. So we end up with 12 there, c squared. Now again, we square root both sides and it looks like we're stuck with a radical here. That's fine, just leave it in simplest radical form. So if you build a little tree there and simplify that, you'll get 2 square root of 3. Okay, so we're going to plug that in right there for that c value, 2 square root of 3. So one of them is going to be 1 negative 2 plus 2 square root of 3. And then the other one is going to be 1 comma negative 2 minus 2 square root of 3. So there's my 2 foci. And then again, the eccentricity is just equal to the c value, which we found was 2 square root of 3, over the a value, which was 4. So you could simplify those coefficients. You'd really have square root of 3 over 2. And that would allow us to find